Okay, let's give you guys an example now. So we're going to try and come up with an equation of a circle in polar form. So we've seen in the previous video, we can specify any point on a plane. Let's say this point here, we can specify this point by stating the angle, and then by stating the radius, if you like, the radius here. So from this, by giving the angle and the distance, we can automatically work out the height. So y will be given by this. And by stating the angle and the radius, we can automatically obtain the x coordinate, which will be given by this. So now we're going to make use of this to come up with an equation for a circle in polar form. And by the way, once you've got the height and once you've got the width here, then you can obtain the angle by using inverse tan. So we can make use of that as well. So the angle can be written as this. And then once you've got the height, and once you've got this length here, you can use Pythagoras to obtain the r. So you can make use of this as well. You can make use of this. So we are going to make use of this, and maybe we're going to make use of this. When you use these two, just use it with caution, because sometimes when you enter the negative realm, for example, the radius. Well, you can, in polar form, let's say the distance here is 7. You can actually say a radius of -7. That would mean starting from here, you would go in this direction. You see, if you look at this, you can't really obtain the negative radius. Well, what I'm trying to say is that when you use these two, use it with caution. It's pointless me giving you examples now. You will understand when you bump into the problem. So I'm just going to leave this for the time being. But this, you can always make use of this. This will always be true. But this here, just use it with caution. Well, let's start again. When given an angle and the radius, we can automatically obtain this. So let's try and make use of this. And by the way, keep this at the back of your mind, okay? So we're going to make use of this. So let's look at a circle. So the equation of this circle is given by this. So now we could do this. We could put this into here, and then we could put this into here. But not yet. We could do that, but let's try and tidy it first, and then we can put it in. So looking at this here, let's multiply this out. Multiply that out. It will then give you this. It will then give you this. Multiply that out. It will then give you this. Now looking at this, cancel out the a squared. That will then give you this. Okay, and looking at this here, remember r squared is given by this plus this. Well, if you look at this here, you've got x squared plus y squared here. So combine these two together to give you r squared. So that will then give you this. Now we can start to put this into here. So this 2a here is this 2a here, and then this thing here is this. Okay, so that would then take you to here, and then that add this to both sides. That will then take you to here, and now divide both sides by r. So these can divide both sides by r. That will then take you to here. So now this is your equation for the equation of this circle. So center A, radius of A. So the equation of that circle is given by this in polar coordinates. If you get a graph plotter and plot it, it will then give you this. So I've made this A here to be 2. So if you look at the formula here, I've made the A here to be 2. So this is this 2 here, and then I've made the A here to be 2. So that will then give us this. Okay, so this is your polar coordinate. This is in polar coordinate form. Okay.